It can be used year-round. It can be used seasonally. That's all a matter of taste and capability based on your climate. As I mentioned earlier, biofilm really doesn't require anything for us to do to grow it. All we need to do is create an optimized environment for it to grow, and it will come, kind of like Field of Dreams, right? If you build it, they will come. If we create an environment that includes a stabilized temperature of water between 50 and 90 degrees, nutrients to feed it, and a source to be able to provide it, then biofilm will just naturally occur. So in those cases, all we're doing is creating a specific type of media. Sometimes synthetic materials can be used, but what we're trying to do is create a surface area. I'll show another picture a little bit later on about the guts of this system. It's actually full of rock substrate, typically limestone, that in that environment, it creates an enormous surface area for the biofilm to grow and proliferate. Let me show you this quick video of here you'll see kind of the guts of the biofilm system. Notice here's water level up here of the swimming pool. So the tops of these filter tubes, in this particular installation, there's 10 of these filter tubes. This is our BF4 biofilm system. The purpose of these filter tubes is to evenly distribute the flow of the water throughout this gravel substrate that surrounds all of these tubes. Inside each of these tubes is a sponge filter that also encourages the growth of biofilm. So the path that the water takes is, first, it will be pulled through the gravel to the bottoms of these filters. You can kind of see, and I don't know if I don't have a picture later that shows you, but there's a thinner piece of plumbing that comes up to the top of the filter tubes that's pulling the water down inside it. So the water is flowing through the gravel down, then up through the sponge, and then back down through that center pipe. And all of these pipes are then manifolded together into one central filtration manifold connected to that pump. So when the valve is on filter mode and the water is moving, water is spreading all throughout this gravel media, encouraging the growth of biofilm over time. How long does it take to grow biofilm? Depends on the time of year. We encourage people to open their pools and start them circulating as soon as possible. So as soon as the water temperature reaches that minimum of 50 degrees, really it's around 68 that really things kick off and grow quickly. Still too cold for me to swim in, but it's at a temperature that begins to influence the growth of the beneficial bacteria and fungi that are going to be resident in the biofilm. And as that grows, it takes about a week to 10 days in those kind of conditions before the biofilm has been fully, we reach a critical mass of the biofilm to really do its biological filtration. Let me also point out there's two other systems in this that are deployed, and it becomes an important part of the maintenance for the biofilm filter. This smaller 1-inch pipe that you see running and crisscrossing throughout the bottom, that's actually an air line. It's connected, it's stubbed up to a pipe at the top of the tank. It's just open. It's usually capped off, but it's there for maintenance purposes. So in the spring, when you are opening up the biofilm filter, the very first thing that we do is we attach an air blower or shop vac or air compressor to that plumbing and blow air through that manifold, and it percolates through the water and gravel, dislodging the dead biofilm that's in there now. Because remember, if you shut the pool off in the winter to winterize it, then the biofilm, because you've shut off the flow of nutrients, the biofilm is going to die. Sorry about that, but now we need to regenerate the biofilm by dislodging the old dead biofilm. And we do that by percolating air through the substrate. Once that's done, it takes about 5 minutes or so of air blowing. Then we turn that filter valve over to a backwash position. And you notice there's another, it's a little difficult to see in this example. There's another manifold down here that's a backwash line. It's got slits in the side of it. So that now when the pump is pulling from the vault, it's pulling this backwash material, this dislodged biofilm, this biofilm sludge. It's a technical term. But I will tell you, I'm a gardener, and I'm always I'm composting, and I love a good natural fertilizer. And folks, this is fertilizer gold. So in the springtime, when you open up your biofilm filter, or even when you're cleaning the pond area in your swim pond, that material that you're vacuuming up is nutrient rich for your gardening needs. I'd highly encourage you to redeploy that for your purposes in landscaping. But that's the only maintenance that's required on a biofilm filter. Typically, that needs to be done about every 120 days. So depending where you are in the climate, you may have a season like in the Sun Belt where I am, where you can just about swim year round, except for maybe February and January. But the water temperature could certainly be suitable if maintained through solar heating. But so long as you've got water flow through there and the water temperature is being maintained in that 50 to 90 range, the biofilm will continue to grow. Now that is a differentiating thing about the biopool with the biofilm. Because the water is moving more quickly, because we're not using plants, and remember now in a bioswim pond with a planted environment, those plants are going to go through their seasonal dormancy the way all the other plants do. You know, this time of year as we're losing leaves and the fall color is looking wonderful and dropping. Well, we know that's temporary. The trees are going into dormancy. They're losing water and draining water out of the trunk so that they're not exposed to severe winter climates. And then when the temperature grows up and the daylight hours get longer, plants take their signals from nature to begin this regeneration of growth. And the same thing's happening in our biopool and our bioswim pond. Now, the biopool can, the biofilm filter can be installed in numerous different ways. I'm showing you two different examples here. You can see in the left-hand example, the biofilm vault is here underneath this deck area. They've raised it up to be a tripping hazard. It can be flush, but it's a modular panel because we do need to get to the top of this biofilm filter during our maintenance time because we're going to pull those sponge filters out to hose those off. I think I got a slide picture of that here in a second. But it doesn't have to be next to the pool. The picture on the right, you can see that it is actually detached from where the swimming pool is, and we just connect it with plumbing. It's a plumbing exercise at that point. We do want to make sure that it's located close enough to where the hydraulics work, where we're not losing a significant amount of head pressure or friction loss in the water flow, and that it's suitable. We want it to be ideally gravity fed from the pool so that we can get the most efficient water flow. I'll also point out from a standpoint of economics and energy efficiency that because these systems are open atmosphere filters, and that's true of the swim pond and the biopool, the amount of energy that a pump requires to move water is not nearly as much as that's in a regular pool. Because see, in a regular swimming pool, the pump is pulling water directly from the pool and then pushing it over into a filter. That filter is pressurized, and that back pressure creates energy or strain against the motor, so the motor has to turn harder to maintain the same gallon per flow rate. We don't have to do that. It's open atmosphere, and we get very efficient operation of our pumps. In fact, in most pools, we can estimate the cost of pool pump operation at about the same as that of a couple of 200-watt light bulbs. Very minimal. And we can, like I said, we use energy efficient, variable speed, programmable pumps. So we can plug in and program it in to deliver the exact flow rate that we need. Because that is one of the parts of the secret sauce of these systems. The flow rate, depending on the biological filter, needs to be maintained according to the needs of the biological filter system that we've got deployed. There's several of the different designs. Your imagination is the only obstacle here. I particularly like look at the installation here on the lower right. Here's the biofilm filter. These are like scupper gutters that are connected to the pool. The pump in this case is located underneath this little hatch for servicing. And as the water pulls from that biofilm filter, water pours from the surface area of the pool into the biofilm system. The biofilm system over here is in the corner. In this pool in the top left, it's here under ornamental rocks at the end. You can also see they've got an ornamental water feature that's spilling out into the pool. That's fine. Here's another one with a zero edge, vanishing edge pool. The biofilm filter is just below that. So any number of types of construction methods can be used to hide this system. And this is kind of the guts of it. The BF4 system, the one that's being showed can treat systems up to 535 square feet of surface area. Let me make a point about that. We are not so worried about the gallonage of the swimming pool as we are the surface area. In a chemically treated pool, that's a little bit different because gallonage is their focus. It's number of pounds per gallon of water to treat it. In a biological pool, we know that all the nutrients that are going to be hitting the water coming from the atmosphere, they're coming through the surface. So we need to know and calculate that surface area. It's through that calculation of surface area that we then size the appropriate size for the biological filter. Like I said, in this case, this particular example, this particular setup, it'll treat up to 535 square feet of water. Now, one caveat, a little asterisk here. If you've got a 500 square foot pool and you've got 3 golden retrievers and twin 12-year-olds with t-ball friends or soccer friends that are going to be in the pool all day, 12 hours a day, then that's a heavy bather load. And the amount of biological filtration needed for that type of system may be different than a similar sized pool that has a different biological need. So we spend a lot of time making sure that we understand how the pool is going to be used and who is going to be using it. It's better to have more filtration than not. So we will oversize and overbuild a biological filter in anticipation of peak needs. There's no such thing as too much filtration in any kind of swimming pool, and that's the case here as well. This is that sponge foam center that you see. See it's got a hole through the center. That's what slides down over that center pipe in the filter manifold. This complicated piece of equipment here is just an umbrella stand. It's the easiest way to slide it on to there and then just hose it off. Do not use detergents. Do not use a pressure washer. Just hose it off with a regular nozzle and then pop it back in after you're finished doing the air feed to bubble out and clean out the biofilm. And it's slide back in and it's ready to go. The typical size, and I'm focusing on this size of biofilm filter because that's kind of the average size pool. 16 by 32, 512 square feet. So for an average size 16 by 32 pool, the biological filter required for that would be approximately 4 feet wide, approximately 10 feet long, and approximately 6 feet deep. Now, we can construct and move and manipulate this area a lot of different ways based on the design needs for your pool. But this is a pretty common method for construction.